Go language programming, chapter 4, unit 2. In this unit, we will cover methods versus functions and methods with same name. Go language methods are similar to Go language functions with one difference. The method contains a receiver argument and the functions do not have the receiver argument. Functions only have the parameters. With the help of the receiver arguments in a method, the method can access the properties of the receiver within its body. The receiver can be of struct type, or it can be also non-struct type. Okay. If you have a non-struct type receiver, and then both the type, the non-struct type, and the method must be in the same package. Of course, right now we have not covered the packages. Very soon we will be going over how to write your own packages, but just remember, non-struct type must be in the same package as the method body will be. Okay, otherwise compiler will generate an error. So basically, let's understand more about what the receivers are and how they are declared. So a method must a method is just a function, So first of all, in Go language, clearly it differentiates the function and the method. Okay, so they both are could be considered as functions as well, but functions cannot be considered as a method. So the only special thing that the method has, it has a receiver, okay, special receiver type. That and where does the receiver go? It goes in written in between the function func keyword and the method name. Okay, so that's where within the parentheses, that's where the receiver will go, and of course you will see it in the code very soon. So the receiver can be either struct type or non-struct type, as we just discussed. The receiver is available for accessing access the inside of the body of the method. So basically, if you have a receiver, then you have access of that receiver within the body of a method. Okay. The following is the syntax to create a method. Okay. So this, in this case, you have a func keyword, which we use for creating a functions as well, and we also use for creating the methods. But when you are creating a method, you have to put a receiver. Okay, so receiver is going to be within the pair of parentheses. Okay, so that's where the receiver will be. Okay, so receiver will be of type either a struct type or a non-struct type. Okay, and for the non-struct type, there is a little restriction that it must be in the same package as this function or this method will be. This is the method name which comes after the receiver. Okay, and then the method will have the parameter list as as same as the function has, and then the body, starting with the left curly braces and the right curly braces. Okay, so within the body you can put any kind of code that you're supposed to your method supposed to have. So basically, above sniff of code creates a method name which has the receiver type. Okay, that's what it will do. So now let's look at in this example 4-7 in more detail, and by having a package main, so we can compile this code and execute it. And then within this code we have an import package, or the import keyword, and we are importing a fmt package. And then at line number 4 we are creating a struct type, or the user defined type called employee. Okay, and within that we have a 3 fields. Each field is on its own line, so they have, they are the name is of type string, salary is of type int, and currency is of type string. Okay, so this is the body of a user defined data type called employee. Okay, now I just want to make sure you understand there's no memory is allocated at this point. Okay, so this is just a template of type employee. Okay, uh, once you create an instance of type employee, that will be the time the memory will be allocated. So show salary is a method. Okay, so we're going to create in this code, there is a method called show salary. Okay, that has employee as a receiver. Okay, so employee will be as a receiver right here, exactly like here. And so then you can access that receiver within the method body. So at line number 12, we are creating a body for the method. Okay, we have the method name and we have a receiver. The receiver in this case we have it is a employee. We are using an employee type within the receiver. Okay, and within the body we can access this receiver. So we are using the dot operator to access the each field from the employee database, employee struct. Okay, user defined type. So e dot name, e dot currency, e dot salary. So we will get basically all these 3 fields accessed from within the body of this struct. Now, whenever you create this method, it is basically becomes just like a other object-oriented language, just like a C++. Okay, uh, it becomes the member of this struct type. Okay, and so because of the receiver, you can access the each fields within the struct. So basically, you are attaching this method to this user defined data type. Okay, as long as you use the that type within the receiver. Okay, so it's very similar to C++, which is in C++ we call a member functions. In here we just calling the method. Now within the main function, which starts from line 16, the body of the main starts at line 17. We are creating a instance of type employee. Okay, emp is an instance of type employee, so that will be created in the memory at some memory location. Okay, and it will have all these data in here. Okay, so and then this memory name will be emp. Okay, so that will be the name of this piece of memory. Now once you do that, and look at the when we are doing the initialization for the struct starting at line 18, we are using the field name, and right after the field name we have a colon, and then the salary, and then the colon, and currency, and then the colon, and then we give a data. Now the last field that we initialize, we have a comma right there. If you don't put a comma, compiler will give you the compilation error. Okay, so this comma in the way that you initialize is important. You have to put this comma in there. Okay, in the last field. So basically, the data will be initialized to this piece of memory right here, and then what once we created this instance, we can use this emp instance to call the method show salary. Okay, so we are using the emp dot show salary. We cannot just make a call to the show salary. Compiler will generate an error. In this case, we are just doing the same way as what the C++ does. In C++, the member functions, if you have it within the class, you have to create a first object, and then use that object to make a call to the instance, So this is basically internally what it is doing is doing this similar thing as what the C++ does. So when you do the EMP was created at what? 5,000, right? So now 5,000 is an address where this memory was allocated. So the address of this EMP is passed to this function internally at the low level. So basically, 5,000 goes in there. So when it goes to this function, show salary, it knows where this data is located. At 5,000, the name is located. 5,002, the currency might be located. Whatever the addresses are, 5,004. I'm just making up the addresses. So that's how it knows, because the initial address was passed in this, within this parameter, and this exactly happens in C++ as well. Okay, so basically that's how the methods are work. They work. So the reason that you have the receiver, so basic idea is that receiver would be used within the body of the function, or within the body of the method, and then once you use them, you can individually access the fields from within the struct that is used within the receiver. Okay, so now let's compare that with the function. What happens, similar thing that if you try to do with the function. So in the next slide, that's what we will do. So the function cannot be attached, So only the methods can be attached to the type, like we did it in the previous example. Okay, we attached the that method to the employee struct. Okay, and use the employee within the receiver. Okay, so that means we attached it, but the functions cannot be attached to any type. Okay, so by default, the type is passed to a function parameter as passed by value. Okay, like we have discussed before, that Go language does not have pass by reference, like the other languages will have. You can pass by pointer, but not by reference. There's a difference between pass by pointer and pass by reference. Okay, and we already discussed it in a previous chapter. So if you need to review it, please go and review that. Okay, so now let's look at how this passing of struct works to a function parameter. Okay, and that will be in example 4-8. So we start the 4.8 with package main, and then we import the FMT package, and then we create a struct, employee struct, which has three fields in there: name, salary, and currency. Okay, and then we are creating a function. Now notice that there is no receiver right here. Okay, so that's why this would be a function. Okay, and but this function is taking a parameter of type employee passed by value. Okay, so now we can still use this line, the same line as we have used it in the previous example, using e dot name to access the fields. So this is all valid that you can do. Okay, so basically the only problem is going to be if you change something within the body of this function, the change is not going to be going back to the caller. So who is the caller for this function? Main routine is the caller. Main function is the caller for show salary. Okay, so in here we are doing the same thing as we did it in the previous example. We are creating an instance emp and of type employee struct. Okay, and using a short notation to allocate the memory for it. So emp will be there, emp. Okay, and all this data will be initialized in within this struct, and basically once it is initialized, you can pass this this instance to the function, to the function parameter, which the function is show a salary, and that will be passed by value. So within the function body, it will do the printing. Okay, but if you do any changes and the call comes back to the caller and try to print, the data, the change will not be there because we pass by value. Okay, so basically as we discussed in the previous example, that methods are the one which have the receiver, and then the functions are the one they do not have the receiver. Okay, so that's how you pass the instances within the function body. Now let's look at the other example. In that example, we will have basically two methods with the same name. Okay, and how exactly that works. So methods with the same name can be defined on different types, where functions with the same names are not allowed. Okay, so now when we say same names of the methods are allowed with the different types meaning different types of receivers. Okay, as long as the receivers are different types, then you can have the same function names. Okay, otherwise it won't work. So in this example 4-9, we are using starting with the package main, so we can compile this code as an executable. And at line number 2, as you can see, there is a little bit little difference than the previous example. We are using a left parentheses. Okay, within the parentheses, we are importing two packages. Okay, so if you have to import multiple package, now I would strongly recommend also that when you are importing the package, is please make sure you are only importing the package in your assignments that are standard Go language package, from the standard library, not the third party libraries. Okay, I would not grade your assignments if you import any package from the third party library. So here, the math package that we are importing it is from the standard library, a standard Go library. So we've been so far only importing the FMT package, so we can use the print function from that library. But right now, we are also importing the math package from the standard library, so we can get the pi, from that library. Okay, that's the reason that we are importing, because I'm using the pi from the standard library. Okay, so at line number 7, we are creating a user-defined type called rectangle. Okay, and it has two fields in there, length and the width. Okay, and they both are of type int. And then we are also creating another user-defined type called circle. Okay, and in the circle there is only one field, a name called radius. Okay, of type float 64. So basically, these are two different struct that will be used within the receivers for two different methods, okay, which will have the same name. So at line number 16, the first method starts with the name of the method is area. Okay, and it is the receiver is taking the parameter of type rectangle. Okay, and area is also returning, so basically this method is returning type integer. Okay, because it has a return function, so after it utilizes the fields within the rectangle, and then multiplies it, whatever the number comes, it will be returned back to the caller. Okay, and then we have at line number 20, we have another function or the method which is the same name as the first one, which is called the area. Okay, and in this case the receiver is different. So for that reason, because the receivers are different for both functions which has the same name, so that is allowed. In other languages, this kind of a thing, if you have the same function names, it is called function overloading. Okay, and basically that creates something called polymorphism. Multiple implementation, single interface. So this is considered as a single interface. That's how C++ calls it. So in here, each method receiver is different type, so we can within the body we can access it. The this receiver within the bodies are used, and in this case we are just reading the data that was passed to this receiver. Okay, now within the main we are actually allocating the memory for rectangle. Okay, as you can see, R is the your instance of type rectangle, and it is using a short notation, colon equals to initialize that piece of memory. So this is the piece of memory which will be initialized at some different location. It will have two fields in there, length and width, and they both will have the data. 10, and 5. So that's how this will be initialized. Okay, and then we are using this R to make a call to the area method. So we are saying R dot area. So when we do that, what will happen? R is going to make a I mean the area method will be called, and R is the one which is so will be when it is calling, like I told you earlier, it will pass the 7,000. Okay, and that's how it will know within the body where this data is located in the memory. Okay, so it will be accessing and writing it to that piece of memory, that data. Okay, I mean, if it does any changes, the changes will be there. Okay, so basically, that's how it knows how to read the data from that specific uh, um, address. When you make a call like this, r dot area. Now, the so when we did this, when we created the body for area, for the rectangle and for circle, we actually attach these method to each type. Whenever you use the type name within the receiver. Okay, and then we create another memory piece of memory for circle, same way as for the rectangle. So this will be for circle, and then in there is only one piece of memory, radius, okay, which is initialized to 12. Okay, so that will be, and then probably it was created at some address location. So that's what it will happen within the main body. And then from the main body, we are calling the area. Now in this case we are using a C, for circle, C dot area. That will call the this method which starts at line number 20. Okay, and when it is calling, this 8,000 will be passed right here. Okay, so it will know where, so the the this fields which is used within the body of the area knows where it is located in the memory. Okay, because of this address. And it will do the in both cases, because we are using a printf function. So printf function, also notice that it is using a format specifier. Okay, so for the regular integer, it is using the percent %d, and for float type, it is using a percent %f. Okay, so don't forget that, for float type, you have to use this percent %f. So this concludes um, uh, Unit 3, Chapter 4.